Okay, for number 5, we have two terms. The term on the left is a composite function. We're taking the cosine of x minus 5. So that will be, we will start with the chain rule. The outer function is cosine and the inner function is x minus y. So when we take the derivative of the outer, we have negative sine. The inner as is x minus y. And now for the derivative of the inner, we know that the derivative of x is 1. And we know the derivative of y is y prime because we have to use the chain rule on y. So the derivative of the inner is 1 minus y prime. And that is our chain rule. Again, the derivative of the outer, negative sine. The inner as is, x minus y. And the derivative of the inner, 1 minus y prime. On the right side, we need to use the product rule. We are multiplying two separate functions together. So we need 1d2 plus 2d1. So the first function is x, so that's 1. For d2, the derivative of e to the x, of course, is just e to the x. And then we come back with 2 as is, which is x, and then we need d1. And the derivative of the first function, the derivative of x, is 1. All right, so there's our product rule, 1d2 plus 2d1. Now let's clean this up a little bit. There's really nothing to clean up on the left, so negative sine of x minus y times 1 minus y prime. And on the right, we have x e to the x plus x. Okay, so we have one big messy term on the left, and we have two terms on the right. Our goal here is to get y prime by itself. In order to get y prime by itself, we have to get the binomial with y prime in it by itself. So we want to move this over to the other side. We want to get rid of negative sine x minus y. And we can do that simply by dividing both sides by that to get it to drop out. So we're going to divide this by the negative sine of x minus y. And we're going to divide this side also by the same thing, negative sine of x minus y. Okay, now this all cancels. On the left, I'm left with 1 minus y prime. On the right, I have a big messy fraction, x e to the x plus x, all over negative sine of x minus y. Now I just have to get y prime by itself. So I'm going to subtract 1 from both sides. So minus 1 and minus 1. So these cancel out. Now I just have to get rid of the negative 1 in front of the y prime. So I'm just going to change the sign. All right? Negative y prime is going to become positive y prime. Now I just need to change the sign. This whole fraction has a negative, so I'm going to change that to positive, and this negative 1 is also going to become positive. Because this is negative y prime, I just multiply through by a negative 1. So my answer is x e to the x plus x over positive sine of x minus y, and then plus 1. And there is my final answer. That was a tough one. Okay, number 6, we start with 4 terms. For the first term, because it's a y, we have to use the chain rule. The derivative of y, implicitly using the chain rule, is y prime. For the second term, we have to use the product rule because we're multiplying two separate functions together. So we need 1d2 plus 2d1. So the first function as is x squared. The derivative of the second function, the derivative of y squared, we have to use the chain rule because this is a y. So the derivative of y squared, implicitly using the chain rule, is 2y prime. So that is 1d2. Now we come back with the second function as is, y squared, and we need the derivative of the first function, the derivative of x squared, we just use the power rule. So that is times 2x. So this is 2 and this is d1. That is our product rule. The third term, 6y, because there's a y in it, we must use the chain rule. So the 6 comes along for the ride. And the derivative of y, implicitly using the chain rule, is y prime. And finally, our fourth term, 4x, that's just a power rule. The derivative of 4x is 4. Okay, so now we have 5 terms. I'm going to underline them. This one, this one, this one, this one, and this one. What I would do is just rewrite it and clean up these middle terms. Put the terms in order so it doesn't look as messy. So leave the first term alone. This second term, put it in order. Put the number first, and then the x, and then the y, and then the y prime. Same with this third term right here. Put the number first, and then the x, and then the y term. And then plus 6y prime plus, it equals 4. Okay, the next step is to get all the terms with y prime in it on the left, and all the terms without y prime in it on the right. So, this term stays on the left because there's a y prime in it. This term stays on the left because there's a y prime in it. This term stays on the left. There's only one term that doesn't have a y prime in it. So we're going to move this term over to the right simply by subtracting it. We're going to subtract off 2xy squared minus 2xy squared. Okay, so on the left we still have y prime, that first term. We still have 2x squared y prime. And then we have 6y prime. Those are my 3 terms with y prime in it. On the right, we have both of these terms. We have 4 minus 2xy squared. All right, now we need to get y prime by itself. There's 3 terms with y prime in it on the left, so remember, we factor out y prime on the left. So we put that out in front, and we rewrite that trinomial, and we divide each term by y prime. If I divide this term by y prime, anything over itself is just 1. If I divide this term by y prime, I'm left with 2x squared y. And finally, if I divide this third term by y prime, I'm left with 6. And then the right side just comes along for the ride. Okay, finally, the last thing to do to get y prime by itself is I divide by that trinomial. So I'm going to divide this side and this side by that trinomial. 1 plus 2x squared y plus 6. And same thing over here. 1 plus 2x squared y plus 6. And there you have it. Those cancel out. We've got y prime by itself. Here is your final best full credit answer. You could, of course, simplify on the bottom. You could add the 1 and the 6 and get 7. But if you can get y prime by itself, this is as far as you need to go. I'm thrilled if you get that far. On to number 7. Okay, number 7, we have 4 terms. The first term has a y in it, so that's going to be using the chain rule. The derivative of y squared, implicitly using the chain rule, is 2y prime. All right, the second term is a product rule. Now, because there's a negative in front, make sure you put the product rule in parentheses because you're going to have to distribute that negative. But we need 1d2 plus 2d1. So let's start. The first function as is 3x. So that is 1. For d2, the derivative of y, we have to use the chain rule because it's a y term. The derivative of y using the chain rule is y prime. So d2 is just y prime. Then we come back with 2 d1. The second function as is y. And the derivative of this first function, that's just a power rule because it's an x term. The derivative of 3x is 3. Okay, the third term, it's an x term, so we just use the power rule. The derivative of x squared is 2x, and on the right side of our equation, another power rule. The derivative of 7 is 0. Okay, so we have 5 terms, and I'm just going to take a second and just clean up this term and put that 3 first. I'm just going to rewrite everything. 2y prime. I'm going to distribute that negative to this term. That gives me negative 3xy prime. I distribute the negative to this term, and that gives me minus 3y, and then I bring down plus 2x, and it's equal to 0. So take a minute, clean up each term, and again, we had to distribute that negative in front of the product rule. Okay, we have 4 terms. The first 2 terms each have a y prime in it, so they stay on the left. The third and fourth term do not have y prime in it, so we need to move those over. So I'm going to add 3y to both sides, and I'm going to subtract off 2x from both sides. So it's going to look like this. On the left, I still have 2y prime and negative 3xy prime. On the right, I have negative 2x plus 3y. Okay, the next thing to do, because there's more than one term with a y prime in it, is to factor out y prime. So we put it in front and we rewrite that binomial. If I divide this term by y prime, I'm left with 2y. If I divide this term by y prime, I'm left with 3x. This right side just comes down, negative 2x plus 3y. And finally, the last step to get this y prime by itself is just to divide. I divide both sides by this binomial. So, divided by 2y minus 3x on both sides. Okay, those cancel. I've got y prime by itself, and here is my final best full credit answer. All right, one more, calculus. Okay, for number 8, I have 4 terms. The first term, I am multiplying 2 separate functions together, so that's going to be a product rule. 1d2 plus 2d1. So the first function as is x squared. The derivative of the second function, because the second function has a y in it, we must use the chain rule. The derivative of y, implicitly using the chain rule, is y prime. Then we come back with 2 as is, d1. So the second function as is y. And the derivative of this first function, because it's an x term, I just use the power rule. The derivative of x squared is 2x. So there's my product rule. Now we keep going. The second term, the derivative of 3x is 3. For the third term, because there's a y in it, I have to use the chain rule. My outer function is sine, my inner function is y. So the derivative of the outer is cosine. The inner as is y, and the derivative of the inner is y prime. So the derivative of sine of y, using the chain rule, is cosine y prime. And finally, on the right, the derivative of 4 is 0. All right, so I have 1, 2, 3, 4, 5 terms. Again, take a second and clean it up. X squared y prime plus 2xy. I'm just going to put this term in order. Plus 3 minus cosine y prime, and it's equal to 0. So clean it up, make sure things are neat. Okay, there are 2 terms with a y prime in it. Those stay on the left. This middle term and this term here move over to the right because they do not have a y prime in it. So I'm going to subtract off 2xy from both sides, and I'm going to subtract 3 from both sides. Alright, so it's going to look like this. I still have my x squared y prime, and I still have minus cosine y prime. Those are my 2 terms with the y prime in it. On the right, I have negative 2xy minus 3. Okay, because there's 2 terms with a y prime in it, remember, we factor out y prime. So we put it in front, and we rewrite that binomial, and we keep the sign the same. When I divide this term by y prime, I'm left with x squared. And when I divide this term by y prime, I'm left with the cosine of y. And of course the right side just comes along for the ride on this step. Okay, and finally, to get y prime by itself, we just divide both sides by this big binomial right there. So we're going to divide the left and the right by x squared minus the cosine of y. X squared minus the cosine of y. Okay, these cancel out. I've got y prime by itself. Here is my final best full credit answer. All right, calculus, that's implicit differentiation.